Hello, my name is Josh Salinger and I'm the owner of Birdsmouth Design Build. We are a residential design and building company here in Portland, Oregon. And standing in front of one of our projects, this is an ADU. It's a zero energy, will actually be a positive energy once we're all said and done. This building is going to create more energy than it consumes on site. And our company is really focused on mitigating climate change through the built environment. So, buildings use 39% of all the, or emit 39% of all the greenhouse gas emissions in the United States. So if we want to make the biggest impact with climate change, buildings are one of the biggest ways we can do that, more so than transportation and more so than industry. So I started this company to really make a difference in our fight against climate change. I've got 2 kids at home and I know that they are going to be dealing with climate change either directly or indirectly in their lives. And so for me to start a company and address this head on is really meaningful and I think will really affect climate change and the people that live on this planet. Okay, everybody, we're here at in North Portland at an ADU that we're building. This one is a zero energy ready ADU, getting this certified through Earth Advantage. And so this project, it's in 798 square feet, got some really interesting features that really drive the energy consumption of this building down, and also focusing on the envelope of some of the embodied carbon. So we've got some interesting stuff to talk about with, we're doing a concrete-free slab on grade, for instance. So this is south pointing this way, and we've got a nice gable pointing that direction. We've got no trees or anything off in the distance there, so we get some really good insolation. So we get a lot of good solar hitting this thing, and when we're all said and done, this little building should actually produce more energy than it consumes. So it's going to be a net positive energy ADU. So really excited to show you some of the features in this one. So ADUs are slightly different than building a new home in the sense that they max out at 800 square feet. So you can't really go any bigger than that. And there's certain lot coverage considerations that you have to take into account. So there's setbacks, there's the amount of permeable area that the site can take. Things like that you have to pay attention to, and sites are usually smaller too. So that means things like soils that are on site for excavation, lumber packages, trying to get materials and trucks and staging, all that kind of stuff can be rather difficult with ADUs. And they're also hooked up typically to the main house, and so all that infrastructure has to get into the main house, and oftentimes that affects the electrical panel and some of the loads in the house too. So a couple things that are slightly different than building a typical house, but more or less ADUs really are houses. They've got all the same things that a house has, they're just smaller in stature. All right, so the first thing we're going to talk about is the most obvious thing here. This is the blue WRB, or weather resistant barrier, that we're using on this particular project. So this product is a SIGA product. It's SA 500, so it's a MyVest is the name of the product, and the SA stands for self-adhered. And so what it is it's a membrane that is vapor permeable, but doesn't allow bulk water to get into it. And it's got a sticky back, so this gets rolled out onto the wall, and then adhered. We've got some nice cork, pressure pliers, because it's got to have that tactile pressing of the WRB in order to activate that sticky acrylic backing that's on there to keep it adhered. So this product is our air barrier, and it's also acting as our weather resistant barrier in this case. So it's got multiple functions. Since it's vapor permeable, it allows vapor to dry to the inside and to the outside. The vapor control layer is actually the plywood, which is behind here, and we specifically chose to use plywood on all of our projects just because it's more resilient than OSB. It's slightly more expensive, but I think if you're building a multi-$100,000 project or someone's home, I think it's worth spending a little extra money to go with something that's a little more durable than just OSB. So the back side of that OSB is the vapor control layer, which is the least permeable part of our entire building assembly here. So that's the part that we want to pay attention to, making sure that we're keeping it warm and letting that vapor out so that we don't get condensation. So Other things to point out here, the air barrier is going to be continuous on this whole building. So it's going to go through the outside of the building here with our WRB. And then on the top, if you can see this little flap here, there's two little spots where it's opened up. This is actually a 18-inch roll of the same product that we lapped over the top of the top plate, and it goes to the inside of the building and then comes around the outside of the building. And so we tuck this WRB underneath that and then stick it to it over there, and that's going to create a continuous air barrier from the outside up over the top plate into the interior of the building, where we will see how that continues through to the other side of the building. So that's how the air barrier is detailed up at the top. And then the assembly, this little vent line that we're seeing right here, it is a vented assembly. It's a foam-free vented roof assembly, and we'll get into that in more detail later, but this is where the air intake is on the lower side of the soffit here. So the air is coming in through here, and then it's traveling up over and underneath the roofing to a vent up on the ridge. So the rest of the air barrier is connected down through the bottom of the bottom plate, and that is connected to our vapor barrier on the inside, which actually travels under the mud sill and then gets wrapped up in here and then connected to our WRB here. So that creates the continuous air barrier right here. Okay, here we've got a really good view of our air barrier, our continuous air barrier, as it goes up over the top plate and into the inside of the house. So if you look up here, you can see that we've got that 18-inch slice of MyVest, that self-adhered membrane going over the top plate, and then the plywood gets stood up, and then our roof framing is happening on top of that. So you can see the spot above the blue stripe is our roof framing, and that's where the the insulation is going to go. Below that is our air barrier, and so when we install this next layer of MyVest right here, it's going to positively lap over the lower layer, but then it's going to get tucked underneath that flap. And you can see how the back side of that membrane right there, it hasn't been peeled off yet. So that'll get peeled off, revealing that adhesive layer, and then that'll adhere to the WRB, therefore creating that continuous air barrier up and over into the building. Okay, so one thing the Birdsmouth team does as kind of a matter of habit, which I love to see as the owner of the company, is they're marking whenever they see like a little hole in the membrane. They just carry Sharpies with them, and they'll just make a little circle. So you're seeing little circles on the membranes all over the place here where there might be a little hole or something like that. Although this might be a little much, if you're going for passive house levels of air tightness, it really doesn't take long. We tend to have the gang have little pieces of tape like this cut into little bits in their bags, so just at the ready. And so oftentimes they'll be walking by and someone will have marked that there's a hole here, and so they can just simply take some of this tape and stick it over the hole and cover it up. So, not rocket science. You could argue how anal one needs to get with these types of things, but it's great to be able to just pay attention. It really doesn't take much time to make a circle, and when coming by, cover it up. All right, so we're going to talk about the foundation here, how this works, and how we're protecting it, and then from there we're going to talk about how that integrates into our air barrier and our WRB. So what I've got right here is an ICF foundation, so that stands for insulated concrete form, and it is 2.5 inches of EPS foam on both sides here, and on the inside we've got this plastic strut where we have clipped the rebar per the engineer's specs into these little grooves right here, and so they click in really nicely. And so we'll pour our footing, or we'll get our footing set up, we'll set these things up and install the rebar, and then the concrete gets poured in here, and that's what creates our foundation. And that's exactly what's going on behind this corner right here that we're looking at. So what we don't want to do is have just this EPS foam be the exterior of our building for obvious aesthetic reasons, but also because we don't want it to get dented or kicked or animals or anything like that chewing on it. So what we've done is we've actually had some sheet metal made that we've done some stainless steel, and that just gets applied to the outside of the ICF, and so that's what we're seeing right here. So it gives it a really nice look and keeps animals and critters and plants and people from kicking and denting and all that stuff. And it's a non-reactive metal, so it doesn't rust or wick or have any other issues with it. So it's a really robust system. This is about 4 an R4 per inch, so there's 2.5. You get R10 on each side of this. So we're getting a complete R20 thermal break on the foundation. So we're really separating this building from its ambient environment. So these things work really good for that. One of the things we try to do at our company is try to do all foam free above grade. We have yet to find a really super great cost-effective solution. There are some out there to go foam free below grade, but this is just one of those compromises we make. So we are using some foam in this building, but this is the only place you're really going to see it here. So as we pivot over here, I wanted to show how we're continuing our air barrier from this WRB on the wall, then down into underneath the bottom plate and into the interior of our building. So what we've got here is our ICF. Before we put down our mud plate, which is just that pressure treated 2x6 on the bottom, we put a piece of this 6 mil green membrane right here. So this is just a polyethylene sheet that is a vapor barrier, so no vapor can get through here. And so that goes down right over the concrete. We just leave it flapping on both sides. Then when we frame our walls, we simply pull this up and just temporarily tag it into the plywood wall right here, and then install our kickout flashing right here. And then this self-adhered membrane, you can see it's just really sticky, even on a cold day like today, will get installed over the top of this. And this connection right here, where this gets sealed on here, is where our air barrier is connected, therefore creating a continuous air barrier from the exterior wall connecting to our vapor barrier under that plate and then into the interior of the building. So that's what's creating our continuous air barrier. This simply just gets wrapped around here, and then again, that's going to get that pressure treatment. We'll come back around and do that to make sure that we're adhering that acrylic to our building really well. And it's positively lapping our flashing here too, so any water that would get behind our siding can drain down, positively lap here, and then this is tilted to the exterior and just simply drain to the outside. Okay, so we're going to talk here about how we detail the rough openings of the windows to make sure that any incidental water that gets in there is not allowed to sit in here and cause any damage and run out, and also how we're going to connect our air barrier to our windows. So starting off, when we do our framing, we take this bottom plate right here, sort of the bottom sill, the rough sill of the framing, and we cut this so that it's at 11 degrees. So you can see here that it's got an angle pointing to the outside of the building. And so any water that could land on here will just naturally run to the outside. So we just do that with the framing, and that itself is angled to the outside. Okay, so once we start applying our WRB, we actually run these sheets just right over the windows themselves. So the WRB is just kind of hanging out in space right here. And then what we do is we just cut that WRB 45 degrees into the corners right here, and then fold it into the rough opening. So it's taking care of the protection of our rough opening for most of the spots here, with the obvious exception of these corners that it creates where we cut that in. So we want to make sure that, you know, this is our air barrier, it's also our weather barrier, so we want to make sure that we're protecting these corners. And so what we do is we take some of our tape. In this case, this is a Sega Wiglove tape, and this is compatible obviously with the Sega MyVest tape, and it's extremely sticky. It's fairly vapor closed, and it doesn't allow any water to get in. So John here, our site manager, is applying this tape. It's got like a split back on it, so he's able to, you know, take off the backing on one side and adhere it, and then, you know, fold it over, and then pull the backing off the other side, and then fold that back up over, therefore creating that really nice tight seal there in the corner. And that'll get pulled over this direction. And so what this does, when we install our windows, is we're going to connect our air barrier on the inside, which will connect to the backside of the Wiglove here, and any water that gets in here will be directed towards the outside. So it's extremely tenacious tape. This stuff chemically bonds with this WRB so that it becomes like a monolithic layer right there. So it's different than your typical bituminous tapes that don't actually bond monolithically. So what John's using right here is the These things are pressure sensitive, so you do have to either roll them out or apply pressure to them to get that chemical, that acrylic bond, to really bond with that WRB. And so we got this great tool. It's just a piece of cork, keyed into just some wood to hold on to with like a felt on the outside. And this is the same tool that we use to go over our WRB to make sure that it is fully adhered right there. So this is an important step that you want to pay attention to when using these self-adhered membranes.